All right, today I'm going to show you guys how to do conversion factors and converting from one unit to another, which is real important when you're doing several different things we do in chemistry. And the one thing you have to understand and is that it's the way we're converting these by canceling units that's important. It's not can you do conversions in your head, because sometimes people can do these metric ones or look up how to do them easily, but when you're doing a conversion for stoichiometry, and you're trying to determine how much product you get in a reaction, you have to link several conversion factors. They're not metric conversion factors. And so if you don't understand canceling units, this doesn't work. And actually this happens a lot of time for some of the very, very best students. They try to kind of do their own way, and it becomes a real problem in stoichiometry so down the road. So just trust me on that. Basically conversions, getting from one unit to another, we'll give you a kind of a common sense example and then show you how to use dimensional analysis to do that. So let's say we have $15. So you got $15, and we want to know how many quarters that is. Let me show you how to set it up using dimensional analysis. First of all, write down what you have first, and then write down what you want at the top of your conversion factor. This is our conversion factor here. So I'm saying $15 is how many quarters. So put quarters there. And then always take the unit you start with and put it at the bottom of your conversion factor, because you have to cancel and get rid of that unit. The rules for units are the same as the rules for numbers when you're converting. If you have the same number in the numerator and the denominator, they cancel. In other words, if you had a 2 here and 2 there, they cancel. Well, if you have the same units in the numerator and denominator, they cancel. So now that we're left with the unit that we want, we will come up with the correct answer if we will just put whatever's equal in this conversion factor. And usually you would take, especially in metrics, you'd go, okay, what's larger, a dollar or a quarter, and put a 1 next to it. So $1 then is how many quarters. It's the easiest way to think about it. $1 is 4 quarters. Now you simply multiply, cross, and divide. 15 times 4, which is 60, obviously divided by 1. So our answer is, 60 quarters. And so that's how we get an answer for that. Notice we have different conversion factors we can use. The rule about what you can put in a conversion factor, doesn't matter what you put there, they must be equal. So we could put $0.25 as 1 quarter. That's the same thing. They're equal to each other. We would still get the exact same answer if we did that. 15 divided by 0.25 is still 60. So again, that's how you use dimensional analysis. This is some work right here at the bottom that can really help you to convert from metric to metric unit. We always start off with that, doing metric conversions. But again, like I said, you have to understand we're using this stuff to just show you how to do dimensional analysis so that you can do chemistry stuff. And again, I'll repeat myself a lot with that because I can't tell you the number of really, really good students that will try to do this their own way. And then when I say you have 14 grams of some reactant and you have a chemical reaction and you're going to get a product, how many grams of product will you get? You can't really cut any corners to do that. So you have to use dimensional analysis to do that. So let me show you how to convert different types of problems. So first of all, going from 36 centimeters to meters, you also have to identify when you need multiple steps. And if you know how many centimeters are in a meter, you can do that problem in one step. If you said 36 centimeters against how many kilometers, you'd struggle with those conversions. You'd need to use multiple steps to do that. So again, you can also use this. Base unit would be the meters. So going from 36 centimeters to meter, I'll show you how you can use this as well. So first of all, write down what you have, 36 centimeters. And what you want, the question, if you're going from a non-base unit, in metrics, non-base meaning it's got centi in front of it. All of these are non-base units here. These are all non-base units. And you're going to a base unit, you can do that problem in one step because there's the base right there in the center of this. So we're going to put meters here. Again, remember what I've said. Whatever unit you start with, it goes in the denominator of your conversion factor. Now we have a conversion factor. Doesn't matter what we put in there. They just must be equal. So the easiest way to do conversion factors for metric again is put a 1 in front of whatever's larger. What's larger, a meter or a centimeter? Meter's larger. There are 100 centimeters in a meter. So 36 divided by 100 there to get our answer. And we'll get that and go from there. So that is 0.36 meters is our answer. Now, you might say, well, how could you use this to work that problem? Okay, if you're starting in centi, which is where you're starting, and you're converting to the base unit, it's telling you that you're going to have to divide by 10 to the second. 100 is 10 to the second. You know, it's 100 times 100, so that's what that is. This and this are the exact same thing. So if you plug that in there, you get the same answer there, 0.36 from there. The next one, millimeters to kilometers. So now notice we're going, in the first one we went from centimeters to meters, but now we're going from millimeters over to kilometers, and you got to go through the base unit and then go to kilometers, and that's the way I would always approach this problem. So that's a non-base unit, that's another non-base unit. In other words, it's got a prefix in front of it. So we've got 1443 millimeters. And now I'm not going to go directly to kilometers there because I don't know, and you probably don't either, how many millimeters are in a kilometer. And so, but we can easily establish how many of these are in a base unit. So when you're going from a non-base to another non-base, go to the base unit again, which would be the meter. Then again, same rule there. There's our first conversion factor. Doesn't matter what we put in there, the numbers have to be equal, but remember, we're going to cancel our original unit. Now you've got to say what's larger, meter or millimeter. 1 meter is larger than a millimeter. If you don't know that, you need to brush up on stuff like that as you're doing these things. And there are 1,000 millimeters in a meter. Again, you don't have to memorize that. We've had people memorize those in the past, but again, just our current situation, you obviously have a resource. So that's just the first part, though. We're not done. We're going to set up a second conversion factor. We're going to go to the base unit, and then we're going to go to kilometers. Same rule. Whatever was in our preceding unit goes here. We always cancel the preceding unit. The preceding unit was meters. Get rid of that. Now we'll get an answer in kilometers as long as we put in the right numbers there. So what's larger, kilometer or meter? 1 kilometer. How many meters in a kilometer? 1,000. So now you multiply across and divide. So 1443,000 times 1,000. And again, we've got, let's see, looks like 1.443 billion. Try to make sure you're in the right zeros there. 3, 6, yeah, looks good. So there you go. So 1.443 billion there. Okay, how many seconds are in a day? Again, a non-metric conversion. Still do the same problem the same way. 1 day. And the average person doesn't know how many seconds in a day. I realize if you're at home or whatever, you could probably go just ask that, Google that. But again, the whole purpose is to understand how to do that using conversion factors, because there are no shortcuts, again, in the chemistry stuff we do later. So what you do is, what do you know is in a day? What does the average person know is in a day? We know how many hours are in a day. What do we know is in an hour? Minutes. What do we know is in a minute? Seconds. And then remember, we do them all. The thing is, you got to see the pattern. We're doing them all the same. Get rid of the preceding unit. Cancel out days. Get rid of the preceding unit. Cancel out hours. Get rid of the preceding unit, minutes. As long as we plug in all the right numbers, multiply across, we are going to get an answer in seconds. So we'd say, what's larger, an hour or a day? 1 day, 24 hours. Larger, an hour or a minute? 1 hour, 60 minutes. 1 minute, 60 seconds. So again, we're going to multiply across there. So we've got 24 times 60 times 60, 86,400 seconds in 1 day. All right, now cube units. We'll pay attention to these. These are a problem for a lot of people. That means this is a cube. That means like this is a cube. And it's going to change our conversion factors is what it's going to do. A lot of people don't realize that. So again, it's just a one-step problem though. Centimeters cubed to meters cubed. Again, we're going from centimeters to a base unit there, so we can do it in one step. So 70.6 centimeters cubed. We're going to go to meters cubed. Again, we always cancel our preceding unit. Always do them the same way every time. What's larger, a meter or a centimeter? But here's the problem. The average person goes, how many centimeters are in a meter? and they would say 100. But I'm like, how many? What's a cube though? Oh, then they'd say 100 centimeters cubed, but that's not accurate. Take this as an example. You know, this is a decimeter across. So if we said how many centimeters are in a decimeter, these are centimeter graduations here. So that's a decimeter. These are centimeter graduations. So 1 decimeter has 10 centimeters in it just as a length. But this is a decimeter cubed. So if I say how many centimeters are cubed are in it, so it's a decimeter this way, a decimeter high, and a decimeter deep, I would have to say 10 times 10 times 10 deep. And so it's a different value. I mean, so 1 decimeter is 10 centimeters, but 1 decimeter cubed is 1,000 centimeters cubed. So you have to account for that. So first of all, so here's what I'm telling you to do. First of all, establish how many. So there are 100 meters in a, 100 meters in or 100 centimeters in a meter. And then, but you've got to cube it before you put the number in. Because again, this is a meter cubed, so it'd be 100 centimeters, length, 100 depth, and 100 high. So it would be 100 times 100 times 100, or 1 times 10 to the 6th. And so you have to know how to get that value, and that this is not accurate. 100. If you actually cubed it in the problem, it would be accurate. But you can't just put 100 in there. Really, is what I'm saying, and just say it's centimeters cubed. That would not be accurate. So it'd be 70.6 divided by 1 times 10 to the 6th. So 70.6 divided by 1 second e, and 7.06. 7.06 times 10 to the negative 5th there, and that would be meters cubed. All right. The next one is a squared unit. It's an area. So again, well, what we can't do is this. So it's 23 meters squared, and we're going to millimeters squared. So put millimeters squared there. Again, it's a base to a non-base unit. Again, we're going from a base unit there to millimeters. We can do it in one step. So get rid of your original unit, like always. What's larger, a meter? How many millimeters are in a meter? There are 1,000. But this would be an area. So it would be 1,000 millimeters one way and 1,000 the other way. And 1,000 times 1,000 again is 1 times 10 to the 6th. And so we cannot plug in 1,000 in that problem. It will be incorrect. So 23 times 1 second EE 6, and let's see, that's 23 million, obviously, and that would be millimeters squared, or millimeters squared, yeah, not millimeter cubed. All right, next one, how to do conversion factors with problems that are complex. So it says gold has a density of 19.3 grams. And I can tell you, again, over the years, that people that write it down the way it's written up there never actually know what to do with these. You have to understand when you see a ratio between two, or a density specifically, or a rate, this means 19.3 grams over 1 centimeter cubed. It is one over the other. That's in the numerator, and the centimeters cubed is in the denominator. And so if you're going to convert both of them, then you have to deal with them one at a time. It wants to convert grams to kilograms, and then centimeters cubed to cubic meters. That's not a crazy thing to do. You just do one at a time and length the conversion factors. So first thing I'm going to do is I'm going to convert to kilograms. Now, again, I'm going to look at it as though that's not even there. I'm just going to go from grams to kilograms. And so again, we're going to put grams there, cancel out that unit. What's larger? 1 kilogram is 1,000 grams. Now I'll get an answer in kilograms over centimeters cubed. But again, it says we want it kilograms per meters cubed, and again that means kilograms over meters cubed. So we want meters cubed here in the denominator, kilograms over meters cubed, and we have to cancel that unit. So we have to put centimeters cubed up there to get rid of it. The only way they cancel is if one is in the numerator and one is in the denominator. Now we just got to plug in the right numbers. 1 meter cubed, again, is not 100 centimeters cubed, because it'd be 100 deep, width and height, and so it'll be 100 times 100 times 100, which again is 1 times 10 to the 6th. So multiply, cross, and divide. Get your answer there. So 19.3 times 1/10⁶, enter, divided by 1,000. 19,300, and again, now it's kilograms per meters cubed. Again, that's a density mass over volume. Another rate there. Last one here, 55 miles per hour to meters per second. Again, biggest mistake, make sure and write one over the other. This doesn't seem to make a lot of sense for some people when they don't write it like this. So this is the same thing as that. So 55 miles, if you're traveling at 55 miles per hour, what does it mean? In 1 hour, you're going to go 55 miles, a ratio between the two of them. So now they want it converted to meters per second. So again, we can do that. Let's do one at a time. Deal with meters first. So we're going to go meters there. So if you ran track, you know how many meters are in a mile. And we got to get rid of miles. 1 mile is 1,600 meters. It's four laps around the track around a mile. So we've got that. And so we got rid of miles. Now we have meters. But now we need hours converted to seconds. So I'm going to go ahead and say we can figure out how many seconds are in an hour. It's an easy calculation to do. If there's 60 seconds in a minute and 60 seconds in an hour, 60 times 60 is 3,600 seconds in 1 hour. So, and look what I've just done there. I have, and this is good on the fly to go, I've made a mistake here. So we're going to get rid of, get rid of this real quick because I didn't get rid of hours. So hours goes here, seconds goes there. We need meters over seconds. So remember, we always got to cancel that unit. So 1 hour, 3,600 seconds again. So we'll make sure we get rid of that. Wrote that down wrong. Now we'll have an answer in meters. When it's meters over seconds, that's the same thing as that. That means it's the same thing as saying meters per second. So multiply, cross, and divide there. 55 times 1,600, enter, and then divided by 3,600, be 24.4 meters per second. Meters per second. And that is it for today. Good luck. You've got some on your own problems you can do to make sure you know how to do this. I'm sure you'll have some Go Formative problems, something like that to do as well. Good luck.